Although this question does not ask for a second derivative and inflection point, we're going to go ahead and find that inflection point here. So to do that, we're going to differentiate again, find the second derivative of that expression right here. So to do this, I'm going to keep the -6 on the outside because it's a constant. I'm going to differentiate the x plus 2, and then I have x minus 1 to the power 3. Applying the quotient rule, I'm going to end up with x plus 2, 3x minus 1 to the power 2. And that's all over the denominator squared, so I'm going to end up with x minus 1 to the power 6. Now that's a pretty big power, but we want to simplify when possible. I've got a common factor of x minus 1 squared. So that's going to simplify. And we always want to simplify this because we're going to deal with much simpler terms when we do this. So I end up with -6. And in the numerator, I end up with x minus 1. Then I have negative x plus 2 times 3, so that's going to give us negative 3x minus 6. Okay, so that's my numerator. My denominator is going to be x minus 1 to the power 4. Simplifying that, combining like terms, I end up with negative 2x minus 7 all over x minus 1 to the power 4. And factoring that negative out, I end up with positive 6, 2x plus 7 all over x minus 1 to the power 4. Okay, so this is equal to 0 at x equals negative 7 over 2, or 3.5. Okay, so I'm going to put that in my concavity chart here. It's non-differentiable at 0, so I have to put that in there as well. Sorry, not at 0, but x equals 1 in the denominator. I'm going to test my concavity. So testing my concavity, I'm going to test it to the left of negative 3.5. So when I put negative 4 in there, the denominator is power 4, so it's always positive. So I just really need to look at the numerator. So I end up with a negative numerator. So that means I have negative concavity through that section. Okay, and then looking at my graph, yeah, that looks like it's negative concavity. Between negative 3 and 1, I'm going to test it at 0. So that was at negative 4. I'm going to plug 0 in. So the second derivative at 0. Testing that, I'm going to end up with positive concavity. And then on the other side of 1, I'm going to just use 2 as my test point. I plug 2 in. Again, that's going to give me positive concavity. So it's going to look like that. Okay, so this is at x equals 2. So there's my concavity chart. Okay, and then working out the x coordinate of this. So if I plug in negative 3.5 into the original function, I'm going to end up with, and it looks like negative 8 over 9. So when I have that, when I plug that in, so negative 3.5 and negative 8 over 9, that's my point there. And that's going to reflect my change in concavity, so my inflection point. So I do have an inflection point right in there, and I can find that using my second derivative. So there's my concavity chart. I can see I have an inflection across negative 3.5, and then I have positive concavity on both sides of that asymptote.